I will be talking a little bit about running ClickHouse in production and some of the lessons that we've learned along the way doing so. So first, a few words about me. I'm a staff data engineer at Cato Networks. I've been working at Cato for just almost 10 years now, since around the time the company was established. And in the past 5 years, I've been working with everything related to data at Cato, doing multiple roles. And mainly, currently, I lead the development of Cato's data platform. A few numbers about our network. Cato has our own private secured cloud, which is composed of over 80 POPs around the world. We have over 2,600 customers from over 120 different countries, with over 40,000 sites and over 1 million VPN users. So we collect a few types of data from the network, and we use ClickHouse to provide our customers with a very high level of visibility of everything going on in their networks at any given time. So a few examples of some of the interesting use cases that we have that we process and keep. For example, we collect statistics from the network about the usage of users over the network. This is a pretty high volume data. We ingest over 2 million rows per second into ClickHouse. This data set has around 20 fields in it and overall 350 terabytes of data that we keep. We have events of specific interesting occurrences in the network. This data is a little bit lower volume, around 400K rows per second, but this one has just a shy of 300 fields in this dataset. We are expected to support additional fields which are being added on the weekly almost, without compromising our performance here. So this is kind of a challenge. This data is a total of 120 terabytes we have in production. And then we have some more other types of data sets and more metrics that we collect, different metrics. Again, here, lower volume of data, around 20 feeds per dataset, but we need to support a high volume of queries and really freshness, when really make sure the data is as fresh as possible. So what we do with this data at Cato, so obviously analytics, we have few dashboards in our web application that we show customers everything that is going on in their network at any given time. We also provide reports to our customers for certain periods of time that we send to the customers. We also support event discovery, so customers can drill down to specific events that happened on their network at any time, so the customers can actually look at the raw data itself and troubleshoot, investigate anything they need. And also we provide alerts aggregations if a customer wants to be notified for any specific events that occurred once or many times. So, for example, if a customer wants to know if there were 3 disconnections over the last 1 hour, we will notify them that if they had. So a few words on what we were doing before ClickHouse is we used Elasticsearch for searching and analytics. It worked really well for us in the beginning when we had very little data. So, but as the company grew and our customers are bigger, more customers, bigger customers, so did our cluster grow, and we ended up having over 100 nodes in our Elasticsearch cluster. It was self-managed. We found ourselves adding 2 new nodes every month in order to keep track with the growing amount of data and queries, which obviously required a lot of maintenance. But really, the real problem was queries just didn't hold. The queries used to time out. Customers were not getting the service that we wanted them to get, and the whole operation was very, very costly. So eventually we made the decision to migrate to ClickHouse. The migration itself was a process. But eventually, once we accomplished that, straight off, we got huge improvements all around, over 40% cost reduction on the first try, between 5 to 10 times faster response time on average, not to mention some of the queries in the past just were not working. So now we get response back in like a few seconds, which was amazing for us. And our cluster shrink to just 4 nodes on ClickHouse for ClickHouse cluster instead of the 100 Elasticsearch nodes that we had in the past. That's a huge improvement for us operational wise. So it was a very big win. And I'm going to show later on how we even kept improving those numbers. Okay, so a few words about our cluster setup. So each ClickHouse cluster we have is composed of 4 EC2 nodes, 2 shards, and 2 replicas with tiered storage on EBS. We recently made the transfer to ClickHouse Keeper in order to keep up with the latest recommendations from ClickHouse, and also maybe try to avoid some of the issues that we've had in the past with the Zookeeper. So that was a pretty smooth transition for us. So we currently have one separate cluster for each large dataset, and a single cluster for a shared cluster for all of our other smaller datasets. So a total of currently 3 ClickHouse clusters, which we self-manage. In terms of storage, so initially we started with tiered storage on EBS. We had our hot disks, which held the data of the last 7 days, plus aggregation tables that we keep. We found that for our customers, usage 90, actually it's even more than that, about around 95% of the queries are for the last 2 days. So those queries will be directed to those disks. We use Amazon GP3 disks and customize them for throughput and IOPS in order to get better writing and reading on those disks. Then we have the warm layer, which keeps data older than 7 days. For that, we use Amazon ST1 disks, which are cheaper than the hard disks, and they are throughput optimized for better reading of large chunks of data. And just recently, really recently, we added an additional layer of storage, which is the code layer on S3. And here we were able to get a 50% cost reduction on this storage, which holds the main portion of data that we have in ClickHouse, with a very reasonable performance degradation. So now we have the option to use this layer as well, which we are currently rolling in production. Okay, in terms of ingestion, we have a service running on Kubernetes, reading Packet files from S3 and ingesting them into ClickHouse. We ingest to a random node every time. We have 1 service per cluster, and we also handle the schema evolution in this service, and we use Liquibase to manage that. Eventually, we hit the limit on the number of rows per second that we were able to ingest into ClickHouse. So here as well, instead of adding more hardware and paying more money, what we did here was add an additional layer of buffering in ClickHouse. It's called a buffer table, which is essentially what ClickHouse will buffer the data in memory before flashing to disk, so less flashes and less parts to merge later on. That really helped us increase the throughput, and we were able to overcome most of the limitations that we hit. Another optimization was to actually ingest multiple files per insert query. So that also facilitated in increasing the throughput. So we currently have no issues there. Anytime another limit is hit, we simply just play a little with the thresholds and these 2 features, and we are good to go. Okay, in terms of queries, we have another service on our Kubernetes cluster. It's a query engine that we developed over ClickHouse. The service has a GraphQL API, so it basically translates GraphQL queries into SQL, And since the service is ours, we also do some optimizations on the query in order to get better, in order to optimize the queries themselves. I'm going to go into those optimizations in the next slide. So we transform the queries into SQL with optimizations and forward the query to a specific ClickHouse node. And we use the distributed table in order to query the entire cluster through a specific node every time. So a little bit about the optimizations that we did, some of the optimizations that we did during query translation. Time aggregations, we added time aggregations using ClickHouse materialized view. We have a 1 hour and 1 day aggregations for every table. During the conversion of the query, we know, looking at the time frame of the query, we know which aggregation we can utilize in order to get better, faster results. Machine stickiness. So we found that a significant portion of the time the query the query runs on ClickHouse is when ClickHouse loads the data from the disk. So, and for our customers' usage, many times we have repeating queries. What I mean by repeating queries is where a customer will start by sending an initial query over some period of time, and then it will probably zoom in a little bit and add a filter or two. And really, those type of repeating queries we can utilize the data already loaded from the disk and utilize the OS cache in order to save reloading this data again and again to the disk by simply directing those repeating queries to the same machine. So we found that the performance on the repeating queries improved tremendously. So that was a nice feature that we did. So basically, queries for the same customer and same period of time will be directed to the same machine. We can add a subquery sometimes if we have a query for a large number of fields. Which again requires loading a lot of data from the disk. We will first query for only time field, then filter by that field, and then using the results from the first query, we will then query the rest of the fields. That helps ClickHouse knows which blocks it needs to load, and that really improves the idea is to reduce the amount of data loaded from the disk. So this kind of helps ClickHouse save a lot of data loaded. We can reduce the time frame. For example, if we have a query for the last week, but with a limit of only 100 rows, we first attempt to run the same query, but on a much shorter period of time, for example, last day. And if we get the 100 results that we needed, we will return them. Otherwise, we will fall back to the original time frame. For our use case, like 9 out of 10, we will get sufficient amount of results back, and we will not have to fall back to the larger time frame. So that also helps speed up the query. And last but not least is the sorting key. Okay. Initially, we started off with some sorting key that after a few POCs, we decided to go with that sorting key. And then we found that we can really, really improve both the sorting and the compression by simply rearranging it or maybe changing it a little bit. On the first try, when we changed our sorting key, we got 6 times faster queries. Queries went 6 times faster and cost reduced by 4, again, because of the sorting and compression. And this is compared to the old sorting key, not compared to the original solution with the datasets. So really, you can get amazing improvements simply by changing a little bit your sorting key. We've done this process, I think, now 4 times, and we just keep getting better and better results for our datasets. The tricky part here is obviously ClickHouse does not support changing your sorting key. So what you can do here is create a new table and migrate your data from the old table to the new table, or somehow support multiple sorting keys on your side. So since we have our own query engine over ClickHouse, we have the ability to do that. This is actually what we decided to do, is simply support multiple sorting keys over ClickHouse. So when we get the query, according to the query and the time frame, we can decide which sorting key fits best for this query, and we can direct it to the right table. That way we can support multiple sorting keys at the same time. And this came in really helpful for us to really make some really great improvements there. We did a full session just on that topic. If you're interested, I added a link here. I didn't go very detailed into that topic, but I think it's a really interesting one. So if you're interested, there is a link to that session. Okay, so those are some of the optimizations that we are able to perform over ClickHouse during the query time, from our query engine service. Another interesting work that we did is for data maintenance. So we have two different types of data maintenance, which is data retention. Daily delete expired data. We are obliged to do so by law. So we partition the data per day and retention period. That makes the deletion itself pretty easy. We just delete or drop entire partition, which is the easiest way for us to delete expired data. The more tricky type of maintenance we do is for deleted accounts, where we have to delete the data of entire account from every part we have. This is a pretty expensive operation since it requires rewriting entire partitions, what we call mutations. So eventually, we do that process once a month. And eventually we found that it is getting a little bit too expensive because many times we've been having some outages on our cluster because of the many mutations that it caused. So again, here we implemented a gradual deletion. We have a cyclic job that gradually deletes all the deleted accounts from a certain batch of parts. Then once it is done, it moves on to the next batch of parts. So we have a better control over the mutations going around in the cluster. In the past, we used EBS snapshots for our backup, which was a very costly event, both for the backup itself, which was a huge expense per day, and the storage cost was really, really high as well. And also data maintenance on that on that backup data was very, very heavy. So here again, we decided to utilize ClickHouse backup commands in order to improve that process. So now we do backup using ClickHouse applicative backup and restore. We store the backup itself on S3, which is much cheaper. And we also found that data maintenance on the data stored in S3 is really easier as well. This is a little high level. I will not go into that, but this is the architecture for the backup itself. So I'm going back to the original slide that we had with the improvements we got from ClickHouse. We actually were able to improve those improvements significantly as well with those optimizations that I discovered, and many more, which I don't have time for in this session. A little bit about monitoring and error handling. We use mostly ClickHouse observability metrics and dashboard for monitoring. Gives us a pretty good visibility and over the cluster. We do also tracking of the system error table in order to track certain errors that we came across in the past. And obviously ClickHouse is open source, so we can always go back to the source code and better understand the problem and finding the solution or the workaround to whatever problem that we have. We've actually done that a few times in the past, and it's really nice every time. A little bit about our future challenges, but I will not go into that. But mainly what we found about ClickHouse is that we can always squeeze in some more optimizations for cost and also performance. So I'm sure we're gonna keep finding more creative ways to do that in the future. So that was it. Thank you, everyone.